Hi, I am Manjunath Nayak, and in this module 10 we are going to learn about diffraction of X-rays by crystal part 1. Here we will learn about the production of X-rays and properties of X-rays. At the end of the module you will know how X-rays are generated, the basic knowledge of it, and properties of X-rays about how they are different from other electromagnetic waves. So, to start with, X-rays were discovered by W. Röntgen, who was a German physicist in 1895. It's an electromagnetic wave of high frequency and very short wavelength. Let's understand the production of these X-rays with the help of a specimen atom here. So we have an atom here, and if by some way, if you can generate a very high energy electron which can be bombarded onto this atom, then that particular electron will give enough energy to the electron with which it is interacting, so that that atom gets enough energy to move out or get knocked out of that atom. Now, because of which the entire atom will be in a higher state or unstable state. Now, to bring this atom to the ground state, an electron from the nearby atom would compensate for this missing electron, and while doing so, an electromagnetic wave will be given out, and that electromagnetic wave, which is formed due to the replacement of the electron from the higher energy level, are known as the X-rays. Now, since in this particular case the electrons have come from the immediate neighbor, that is the nth neighbor in the K shell, such particular X-rays will be known as K alpha X-rays. In case the electron had come from the higher energy into the inner shell, then it would be called as K beta. Also, you must have heard about X-rays of L type, L alpha, L beta, and so on. So what are these? Instead of these electrons coming from outside, high energy electrons, instead of interacting with the kth shell of the atom, if it interacts with the lth shell, then the X-rays generated due to the replacement of this missing electron from the lth shell will be known as L alpha, L beta, L gamma, depending again same as the K alpha, K beta, from where the electrons have been replaced from the higher energy shell. So the X-rays which are generated are of two types. One is the Bremsstrahlung lung, and second one is the characteristic X-rays. What is the difference between Bremsstrahlung lung and characteristic X-rays? Now, Bremsstrahlung lung X-rays are caused due to the deceleration of fast moving electrons. The fast moving electron from the filament which comes and bombards with the anode material gets strongly decelerated and also causes the X-rays. Now, such X-rays are called the Bremsstrahlung lung X-rays. So this entire hump-like thing or pattern is the Bremsstrahlung lung type of X-rays. Along with it, you also have something called the characteristic X-rays. As the name suggests, characteristic means it is very much to do with the character of the material. It is material specific. So if the spikes which you see will be very much to do with the material that is used in the anode. Especially we use materials such as copper, molybdenum, and in some cases even silver. And those specific materials will have specific characteristic X-ray with specific wavelength which help us to find the crystal structure. Therefore, it is the study of their characteristic X-rays that leads to the determination of atomic structure. So, since we have understood that we need a very fast moving electron to go and bombard into the anode material, which is the basics now of producing the X-ray, let us understand with small experimental setup about how X-rays are produced. So for that you need a Coolidge tube. This tube is highly evacuated completely with two electrode materials. One is a cathode material and another is an anode. Now, cathode is mostly a filament from where the electrons will be generated, and these high energy electrons will now go and bombard with the anode material. So as I told you in my previous slide, this anode could be either copper, molybdenum, or in some cases silver, and the result of that would be the X-rays that are formed. In some experiments, they will keep a film just ahead of this X-ray to filter out the unwanted wavelengths, so that they get only very specific wavelengths coming out from this filter and interact with the sample kept in front of it and do the X-ray studies. So now that we have understood the production of X-rays, let us understand the different properties of X-rays. X-rays travel in a straight line and not deflected by electric and magnetic field. So being very high energy waves of X-ray, they travel in a very straight line with a very high intensity, and they do not get deflected by electric as well as magnetic field because they are neutral electromagnetic waves. Next, electromagnetic waves X-ray electromagnetic waves are in the wavelength of range 0.01 to 10 nanometers. This is very important because we are using X-rays for understanding the crystal structure, and the atomic distances in the crystal structure are in this range. We will discuss more about this in detail in the next module. The X-ray ionization ionize the medium through which they pass. Also, X-rays produce a fluorescence in different materials like barium platinocyanide, rock salt, etc. Next, X-rays are highly penetrating. Now this property of X-ray is very helpful in a lot of fields, such as medical field. It can be used to check the fractures or cracks in the bones. Also in civil engineering line or materials line, it can be used to check the interior fractures of the material also. X-rays are absorbed by foils of metals of high atomic number like gold and lead. These are the references. First one is Introduction to Solid State Physics by Charles Kittel, 8th edition, 2004. Solid State Physics by S.O. Pillai, McGraw-Hill, and Solid State Physics by Gupta, Kumar and Sharma. Thank you.